Okay, problems from 5.2, and this is starting with number 47, and all these problems from 47 through 56 are all using this fact that the integral from 0 to 1 of x cubed dx is 1/4. So I'll do a little sketch of it. You can see your cubic function here. At -1, it goes through the point -1, -1, and the point +1, +1, so it curves like this. Okay? So they want you to evaluate these. First thing they want you to do is from -1 to 1 of x cubed dx. Well, it's an odd function, so it's symmetrical to the origin, so this is going to be the same as down here. So this would be 1/4 here, this would be 1/4 also, so these areas would be the same, except this is below the graph, so that would be evaluating the integral, that would be -1/4 plus 1/4, so that's going to be 0. So this just zeroes out because we have the same below the graph as above the graph. So that's always going to be 0 integral. Okay, on number 48, well, I kind of drew a sketch, and all we're going to do is we're going to have the same cubic function, but it's going to be a vertical shift of +3, so I'm going to move it up 3. So should have labeled my points there, sorry about that. This is 1, 2, and 3. And 4 of you. Okay, so it's going to be shifted up 3, 1, 2, 3 units, and this is going to look the same as this, except it's just going to be a vertical shift of 3. So again, this will be 1/4, and this is starting at this line, this horizontal line 3, y equals 3. So below here I've got basically a 1/3 rectangle, so the area of that rectangle will be 3, plus 1/4 will give me the area under the curve, which is the integral, so it's going to be 3 1/4. So I hope that makes sense to you guys. Okay, I hope you can see this little 1/4 here. That's the same thing. So all those will always be 1/4. Okay, so this is 1/4. I guess up here I hope you can read all that. Yep, that's 1/4, 1/4. Okay, let's take a look at 49. Now 49, this looks like it's going to be a little strange because we're going to take the integral from 2 to 3, but I've got x minus 2 cubed. Now this will be a horizontal shift to the right. So if I go to the right, instead of going through the point 0, 0, 1, 2, it's going to go through the point 2, 0. So it's going to look like this. And then we're going to take the integral again from 2 to 3, so it's going to be the same thing. So it's going to be 1/4. So it works out just with the shift being the same thing. Okay, number 50. Okay, this one will require probably a little bit more intuition. This is the absolute value of x cubed. All right. Well, x cubed is going to have these values here, right? It's going to go like, normally it will go like this, I guess. It goes like this. Okay. So these are the vertical values. So for 1, it's going to be 1. Now, if I take the absolute value of x and then I cube it, well, what's the absolute value of -1? Cubed is 1. And the same thing with 1/2. When I take 1/2 and cube it, I get this point here. Well, if I look at -1/2 and I take its absolute value, I get 1/2, and I cube it, I'm going to get the same value. That's going to be 1/2 cubed. So it works out that when I take the absolute value, I just kind of end up with a reflection. Okay? Again, take any, like if I have 1/8, what's my vertical value at 1/8? Well, it's going to be right here. Well, if I take -1/8, and I take the absolute value of that, that's going to be +1/8. It's going to have the same vertical value. So it just ends up being reflected across the y-axis. Well, if this is 1/4, that will be 1/4. So 1/4 plus 1/4 is what? 1/8. And I didn't write that down, excuse me. So hardest thing about these problems for me were the sketches. So 1/4 plus 1/4. Oh, that's not 1/8. It equals 2/4, which is 1/2. Pardon me. So that was my area, 1/2. 1/4 plus 1/4 is 2/4, which is 1/2. Pardon me. Okay. So that's what we had there. Okay. And then number 51. So here's number 51. and we're going to take the integral from 0 to 1 of 1 minus x cubed. So this is the same thing as negative x cubed plus 1. Okay, what are we going to do with negative x cubed? Well, we're going to flip it across the x-axis. So if this is positive, that becomes negative 1. So it's going to look like this. So it's going to be the same thing, except it's going to be flipped across the x-axis. So it's going to look like this. So first of all, we're going to do a reversal of it. So it would look like this, but then I'm going to have a vertical shift of it. So I'm going to go up 1. So this would look like this, first of all, with just the minus x cubed, but then I bring it up 1, it's going to look like this. Okay? Well, I don't want this area. I want the area under the curve here. I want this area. I'm looking for this area here. All right? Well, if I look at this square, actually, because it's going to be a 1 by 1 square, because this is the point 1, 1. All right? Then the area of this whole square is 1. Well, what's 1 minus 1/4? Well, 1 minus 1/4 is 3/4, so that's what you get. Okay? So it's a combination. Again, if we started with this, that looks like this, and then we flipped it, we took its negative, it would be down like this. And then if we moved it up, it's like this. So the area of I'm looking for my integral is the area under the curve from 0 to 1. Okay? Sorry about that. I don't put my zeros in all the time. It's probably put all these zeros in. I label the axis. I'm really fussy about labeling the axis, but then sometimes I don't put all my zeros in. Okay. So again, this area is going to be 1. 1 minus 1/4 is 3/4. Okay. All right, number 58. This is kind of intuitive. It's the same idea kind of as we had in number 47. Okay, 47, we had the same amount of, we're going from left to right, and we know it's symmetrical to the origin, so we have the same amount of above as below. So this would be the same thing. I'm going from -8 to 8. I have the same amount above the x-axis as below the x-axis. I'm going both directions. So they're going to cancel each other out. So the value of the integral will be 0. All right? Not the total areas. The total areas will be different, but actually the integral is just anything that's below the axis, that's negative. Anything above the axis is positive. And I have the same amount of area above and below the axis when I'm going from -8 to 8. Okay, and then number 55. Again, now this is x cubed, so this is my x cubed, which was like this, except I'm bringing it down 1, so I'm shifting it down 1, so it's going down here. So instead of being up here, it's down here. Well, we still know this area was 1/4. So again, if this is 1/4, and if I look at this rectangle, or pardon, this square, it's a 1 by 1 square. So if this is 1/4, the area of this will be 3/4. But since it's below the x-axis, the value of the integral is -3/4, because that's area below the x-axis. Okay? So I hope you think about those, because those are pretty good exercises in using areas and coming up with the value of the integral, the definite integral, which is just the area under the curve. Okay, I hope that makes sense.